last video, I went over a couple problems where we're finding angles. We've got parallel lines and a transversal. We'll do a couple more now that are going to be a little bit more complicated. So, look at this problem here. It says, in the figure below, two parallel horizontal pipes are joined by a third diagonal pipe. Find the value of x. So in this case, we're used to, so far, looking at situations where we've got two parallel lines, like this, and a transversal. And then we can figure out, okay, are angles acute, are they obtuse, are they congruent, are they supplementary, and all that stuff. Here it's a little bit different. What we want to really do is make it look like problems that we're used to seeing. Okay. One way to do that would be just say, well, horizontal pipes are parallel, so I'll just make it draw my line, like I was drawing two parallel lines. Okay, the diagonal pipe is my transversal, so I'll just draw that like it's transversal. And now I start to get a picture that's a little bit more like what I've seen before. It looks a little bit like this picture right up here. If it doesn't look enough like that picture, actually redraw it. Okay, parallel lines, transversals. These are like my two pipes. Here's my diagonal pipe. At 45 degrees, where is it? It's right in here. X is right down here. Now I can see a little bit better what's going on. And I've got the same side interior angles, acute, obtuse, so they're going to be supplementary. So that means 45 plus x equals 180. That's my equation. So x is going to be 135. I'll look at a problem like number 6, number 7 down here. Here I've got multiple parallel lines, and this can be a little bit confusing sometimes. What I'm going to do is ignore one of them. If I want to, so I've got 117 here, I know. I've got x down here, which I'm looking for. I know that it tells me that P is parallel to Q and M is parallel to N. So, here's M. Here's N. They're parallel. 117 is on P, so I'm just going to ignore Q for now. In fact, I'm going to kind of cover it up. Pretend it's not there. Okay, now I've got my familiar situation, two parallel lines and a transversal. If this is 117, then each of these other obtuse angles is 117. So, obviously that's 117. That's vertical angles. 117, 117. Okay. Now, down. I know P is parallel to Q. I want to figure out what x is, so to get from there, I'm going to cover up N. And treat N as my transversal. P and Q are parallel. N is the transversal. Okay, if this angle is 117, then this angle here is 117, right? Those are alternate interior angles. So all the obtuse angles are going to be 117. Okay, now I've got a situation. Well, if this is 117, these two angles have to be supplementary. They have to add up to 180. So if this is 117, this is going to have to be 63, right? Because x plus 117 is going to be 180. Look at number 7 here. Similar kind of thing. I've got parallel lines. Parallel lines. Okay. I'm going to cover up one of them, right? So I've got, I guess I'll do it this way. I've got L. This is P. P and Q parallel. N is my transversal. Is 77 is this acute angle. And every other acute angle in this picture is going to be 77. 77, 77, 77. Now, moving over this way. I also know M and N are parallel. And I can either use P or Q as a transversal. I'll use Q because Q has X's on Q. Okay, this is 77, this is 77. Those are my acute angles. All the acute angles over here should be 77 too. So 77, 77, and I've already got my answer. X equals 77. One last kind of problem. Let's see. Something. Number 12. It says the figure below is a rectangle. In a rectangle, opposite sides are parallel. Use this to solve for x. So opposite sides are parallel. That means that AB is parallel to BC, and BC is parallel to AD. See how I mark it? The one set of arrows means those lines are parallel. Two set of arrows means these lines are parallel. Okay. Now, I want to make this this look like the pictures I'm used to seeing, right? The pictures that are like, parallel lines, transversal. One set of parallel lines, one transversal. But look at this. What are the things that really matter here? Well, the two angles that I'm concerned with, 3x minus 8, 4x minus 51, they are at the intersection of lines A, B, and DC, and this diagonal. So that's all I really care about. I'm just going to draw that over here. A, B, here's my DC, and then here's my diagonal. Now I'm going to write in what I know. I know this is 4x minus 51. That's this one. This is 3x minus 8. Right? That's this one. Now when I look at this situation over here, it's pretty straightforward. This is an acute angle, and this is an acute angle. So those two acute angles are going to have to be congruent. Alternatively, they are alternate and interiors. They're alternate interior angles. So alternate interior angles are congruent. So I can write my equation. 3x minus 8 has to be equal to 4x minus 51. And do some algebra, and you should get x equals 42.